Good morning. Some people are still having some drinks behind. I'm from the Modeling Value Group. We are a Dutch company providing services for model-driven projects. And we have created some beautiful stuff in the open source world, which is called Dclare. And I'm going to tell you what it is and why did we do it. And we have created an integration in MPS for it. And I'm going to demo that integration. So we have a lot to do in 45 minutes. Nevertheless, if you have a question, pop it up immediately because I like integration. Yeah? We'll see how it is. That's not what I want to do. Okay, so we build complex systems. Yeah? And complex systems are not only complex because they have many objects and many values, but also because they are dynamic. If you create a language, then it's not only about the structure, but it's also about when do you do checks, do you know the errors, how do I project it. So there's a lot of dynamics going on if you use a tool. And it becomes very complex. And you have to grab that complexity in some way. Yeah? And this presentation is about a new solution to grasp that kind of complexity in a declarative way. So if you look at different languages, and it is probably a quite controversial slide, nevertheless, you have two dimensions. It's a way to look at it. We have this level of languages which are very imperative, meaning, you know, the word imperative means opdrachtsgewijs in Dutch. It means you tell the computer what to do, when, which step to make. So it's very low level. It's computer oriented actually. And we have a higher level where we abstract away from the actual computer and try to grasp the functionality that we want to realize. Yeah. The other dimension is whether it's multi-purpose or not. Can we express any problem, how dynamic or static or whatever it is, in the direction. And then you see that DSLs are a little bit here. And if you look at the meta DSLs in MPS, they are not even here, but a little bit here. Understand what I mean? So it's not really declarative from that point of view. If you see logic, programming, and pure functional, and I could switch them on, that's not really relevant, then they very much abstract away from the computer, although you can't use that for any purpose. Although some people would say functional you can, but they need monads, and actually you introduce imperative concepts again, and you have the same problem back of the complexity of the behavior. So imperative language, you can express everything fine, and however, the complexity becomes, if the complexity becomes high, it's very difficult to reason about the consistency of your specification. Especially if you use things like multi-threading, etc. Because the whole world is changing, you're not the only one that is in control. So what we try to do is to fill the gap and create Dclare. Yeah? It's not that I'm against DSLs, on the contrary, it's that all these DSLs share the need for creating declarative DSLs. And you can solve the declarative aspect on a generic way. So why don't we do that? And this is a way to illustrate that it is actually possible to do so. Yeah. Dclare itself has different flavors. There is a Dclare engine within Java. We have a kind of API which makes it very easy to write any kind of application in Java, so that you can use ordinary Java concepts to write declarative specifications. There is also an integration in MPS, that's one that I'm going to demo today. And there's also for EMF, although this is proprietary. So this is all open source, available. is proprietary, and we run it for a couple of customers. The basic principles of Dclare are, it is rule-based. It's object-oriented still, but it is rule-based. You don't have methods that you call, but the rules are automatically, magically enforced. It's rule-based in a way that all the invariants, so in the rule you express invariants, hold at the end. So you don't have to think about that. And if you do things that are in conflict, you will get a notification for it. So semantically, all your statements are not in conflict, provenly. It's declarative, it abstracts completely away from threading. Actually, it's run on multiple cores, but you don't have to think about it, because we separated that from the semantical aspects of the language. It's incremental, meaning that you have a minimum amount, but not less and not more, of rules that are re-triggered if the world is changing. And the world is only changed for those parts that are really need to be changed. So it doesn't recalculate the complete world, but only that portion that is impacted by the change. So as local as possible. And it's reactive, meaning you don't have to push a button to start Dclare, it runs on the background, and it keeps the world consistent all the time. Automatically. If we look at MPS, currently we have just added as a language aspect, and you can build transformations with it, and this is the transformation that I'm going to demo later on. Not only what the end result is, but I'm trying to build it in 10 minutes, complete transformation, specified in DclareForMPS. You can also build interpreters. This is what I'm going to demo, but I'm not going to build it on stage. It's a problem solver, namely a sudoku solver, which is a kind of interpreter, and it works directly on the table construct of MPS and the play sudoku with a lot of help.
How would you define the difference between transformation and interpreter in this context?
Sorry?
How would you define the difference between interpreter and transformation in this context?
The question is how I define the difference between transformation and interpreter in this context. Actually, I don't think there's a difference.
Exactly.
Yeah. So it's a kind of artificial distinction, but if you look at the principal things that you have to solve, they're actually the same thing. We didn't need a specific extension for DclareForMPS to do either both. Although we didn't, if I look, so currently we have this problem. If you have the type checker, the transformation, interpreter, the editors, we have different DSLs in MPS. And not only in MPS, but also in other model-driven stack solution. And many times, if it becomes complex, then on the semantical level, so not so much on the syntactical level, because we can integrate that easily on the syntactical level, but on the semantical level, it's difficult to reason how they all work together. If you do type checking, while retransforming your model, where is the transformation currently? It's actually a kind of imperative process with different steps that rewrites the model underneath it. So how can you argue about the consistency of the type at that moment? And can you use the type also in your interpreter? So it would be nice if we can solve this, because this is just any imperative solution has problems with integration, because you have to fit into some control flow. But if you make it declaratively, and the next then we are of course in heaven, so because then it's just is reduced to a set of rules which are all true automatically. You don't have to think about it anytime. Yeah. So that's usage of a declarative concept in the context of DSLs for languages, meta DSLs. Yeah? It's not that Dclare is something that is specifically for that. It's a generic purpose language concept, but we have integrated in MPS for this, for solving this problem.
One more question?
Absolutely.
went into when we tried to build an interpreter with something that was originally intended for transformation was that the interpreter needed an environment for call stacks and for values. Because the difference there was that an interpreter works with, if you will, multiple instances of the same code in the. So that wasn't totally trivial.
Yeah, we have a solution for that in DclareForMPS.
Okay.
So you can also not only notice and models and repositories and projects and all these things are just first class citizens, but you also have things like structs, which are part of the tree and your instance level, but you can also make temporal notice if you like that, if you want to display your interpreter state in a projectional editor, for example. So you can mix persistent and non-persistent models in any way you like. And this is the solution to that problem. So what I'm going to demo is how you eventually how you define those rules for a transformation. And you see there's just a new language aspect. It's just a full-fledged language aspect as that you are used to in MPS. So you can use the plus, and you see if there are rules set for a specific concept. And of course, you have an extra tab. And these kind of ordinary things that you have for any language aspect is supported. So it's well integrated in that sense, in any sense. You can define rule sets, and actually within a rule set you can do more than only rules, but I will explain that later. But you can define rule sets for any concept. For example, if I have a concept entity somewhere, it's pretty here, and I create a rule set for it, just as I do a behavior. But we don't like behaviors, of course. We like rule sets. But you can also create a rule set for module. No problem. Yeah? Which means that if the module imports a language in which you have defined this rule set for a module, then all the rules apply for the module. For example, a rule that creates a model. You can define it in what level. So it's complete the concept for the complete model, including the modules and etc. You can define attributes. So these attributes are volatile. They are not shown, and you can't do that in a projectional editor. But for example, this is a target model. So it's, and you can have any type that you like. Yeah? So it's not as an attribute in Nodus, which is quite restricted on the types. It's where am I? It's any type that you like. But it can also be a node that you refer by such an attribute. And that's how do you specify an interpreter with extra state, more than only the nodes that you have in your specification. The rules are actually just described in base language. So we didn't invent a new language, we just used base language. And perhaps that's difficult to grasp because as a community we always create a new DSL if we want to solve a new problem. But most of the problems are on the semantic level, not so much on the syntactical level. So in base language you can perfectly define constraints. For example, the value of a certain attribute should always be equal to something. Like this target should be know the class, and I have a light quotation. It's just light quotation as we are used to in base language. So, but this is then a constraint. It means it's always the case. So this attribute will always hold a node of the type class where its name is derived from the name of my entity. And where the properties are some function. I will explain it later. Okay. The quotations are, including actually also the copy, have slightly different semantics. They are incremental, which means that you're not going to calculate the object over and over again if something changes, for example, the name, then only the name is changed of this object. So actually it's shortcut for a bunch of rules that keep all these statements, all these invariants alive and hold. And the copy is the same thing. So if you create a copy of something, then you have just a clone, and the clone is incrementally automatically synchronized with the original. So you can partly transform and clone and do whatever you like, and you do that in quotations or even real quotations. You don't need to have light quotations. So you actually can create a transformation with the target language defined in the syntax of the target language. I'm going to sit. Here we have a simple transformation. I already created the transformation, and I'm going to just demo what the behavior is if you have defined such a transformation. There are two languages involved. It's NIAM. Who knows NIAM? Who knows fact-based modeling? Yeah, okay. So this is a flavor of fact-based modeling. It's invented by our own Professor Mason, which is this guy, and it's quite famous in 2 countries. Australia and Netherlands. So it's quite on the globe. However, there's also OO. Who knows OO? And what we have created is a transformation between one and the other. And the interesting thing of fact-based modeling is that if you look at a model here, it just sums up the object types, and they can be lexical or not. It's another word for primitive or not. And you can create fact types, kind of relations between the object types. So instead of in OO we actually create attributes on the class itself, we connect them by facts, but actually it has the same semantics. So it's just a different way of defining a structure, if you like. And there are some advantages and disadvantages if you do it like this. So what I did is just create a transformation. And this is a very simple structural conflict, because the containment of your input model is different than your output model, which is always a little bit problematic if you create a transformation in MPS, because then you have to do a kind of pre-processing or other derivation of objects, etc. Because that's actually a kind of rewrite system where you just replace a portion of your tree with another portion, so the tree structure should be similar. Okay, so what is the behavior? Here we see a customer has a name. The name is of type text, so that's the lexical type, and this is the non-lexical type is defined over here. And here we see the customer has a name. And it has orders, and it has an opposite, because we have captured here information not only what references it has, but also what is the inverse, the opposite reference from it. It's one of the advantages of fact-based modeling. Yeah. So we capture that in the OO model with this ad hoc notation. We say this is the opposite of the other. This is actually MOV. If you know MOV, who knows MOV? Made object facility. It has the opposite construct on the property, and it's exactly what UML does. Okay.
If I understand well, then at the right side the OO concept.
Yeah, so on the right side are those types, as we see on the left side in the fact-based modeling, but then as different classes in the OO. So in the OO language, classes are root objects. And in the fact-based modeling, the whole model is a root object. It's just as it is. Okay. So if I change here customer to order, so I don't want to have a customer name. Now an order should have a name. I hate this. I think the problem is that I left it yesterday evening. Instead of there's one thing we have to fix.
Want to answer the question in the meantime?
Absolutely.
Okay. At LangDev, I asked you about performance and scalability. You
Yeah.
said you didn't do any tests yet.
Yeah, we did.
Good.
So it's about if you have a large model with rules, then you have to multiply the footprint of your model if you read it into memory with a factor of 4.
To get the memory.
Yeah. So if you have 1 million nodes in a model, then you're about 2.5 gig, which is gig. So if you compare that with the transformation currently, it depends a little bit on the depth of your transformation because it copies the model multiple times. If you have one big model and you transfer it, you run into memory issues also now. But it's actually less. So if your target model doesn't have any rules, then it's only multiplied by 2 less. So if you add that up and you compare it to what we currently support in MPS with transformations, then you actually need less memory. Yeah? So, however, and that's one of the things we are solving currently, MPS actually scales up from memory because it is lazy. It doesn't read everything, it only reads the thing that you're showing, it only acts upon it. So currently our engine works on anything which is changeable where rules apply. And of course, this will force you to read in a lot of stuff. But since things are incremental, even deferred incremental, so even if you stop the system and later on start it again, it will resynchronize incrementally, you can actually do it lazy. But that's something that we have planned in the future to solve.
I mean, shadow models has the same challenge, and there we're looking into the user being able to say, hey, I know I'm just working on this solution, so you explicitly limit the scope.
By the way, you see, I restarted the system, the model is still there. So I didn't and I've proven my point before. So my bug is also nice because it proved that now the name is over there. Yeah? So even if you restart the system, it won't calculate the new model over and over again because otherwise the editors will be gone. But now I'm hopefully in the situation. Yeah. See? So it moves perfect. So here I just change the reference, but on the other side I create a containment structure and alter the containment structure. And of course, if you do the name, then the name, and if you do another, you see there on the left, there's a new class. If I remove it again, then it's removed. But you get the idea, probably. Yeah? Sorry? Yes, but only if you define it. So we support it because it has what we call push-out semantic. So if something changes, then other things are preferred to change than the things change back. Because if you change it back, all rules will hold, because that's per definition the case of the system. So it has push-out semantics, meaning that the rules that read the thing that is changed have higher priority than the rules that write the thing that you have changed. And if you create a transformation which goes 2 ways, and of course it depends on your domain whether that's possible, whether it's always possible, then, or partly will be possible, then it will behave in that way. This is not such a transformation, so I can't name it. Clear? Okay, so now I'm going to, because I'm running a little bit out of time, I'm going to the no rules branch. See. So I have the same example here, and I will rebuild it because otherwise the engine is still running on the rules that are defined. It's just working as any aspect in MPS. And if you see now that in Neon we don't have any rules. So I hope I will finish it. First, let's do the obvious. So we have some structure here and we have an object type. And an object type, let's just close the other stuff. An object type, if I look at the hierarchy, then you see we have the lexical and the non-lexical types. Before. So I first want to create something that defines the semantics of this object relational constructs in the OO word translation. So I need to do something like, well, any object type is some type in the OO world. Yeah, that's what I have. So any object type has also something as an OO. I don't know it because it's different probably if you have a lexical or non-lexical, but you can add rules on the specific classes, nodes, concepts for that. Yeah? The other thing, which is just a convenient thing, you notice that the rule that the roles on effect refer to the object types, but it's very nice if you can navigate in the other way around. And normally you need to get all the objects and find the one that refers to me. That's the normal practice. However, we have something which is far more efficient for that. So we have the roles. So I'm going to navigate to the roles in which I participate in the different facts, fact types actually, roles. Now this is our first move. Okay. So what I say is this. Oh, I forgot something. Rules actually transform the structure of OO and so this gives me access to those languages. Just have to define it more easy. So this, and then I have, how do you see it? You know the tilde from OCL? Jos knows it. Okay. So it means I'm going to navigate this reference. This is a reference that we defined over here in the notes, but the other way around. And this is done efficiently. In the background, it's kept in sync. Because otherwise we need to run all the rules on all the objects and see which object refers to me. And of course, that breaks locality. Okay. And then we're done here. And of course, we need to create a model. It's not enough to just create nodes because they have to be contained somewhere in the model. And how do you define that? You define that on a module because that is the owner of the nodes. So I go to here and I create a module rule set. And a module rule set has a model. And we call it the OO model. And actually, there's a convenient thing. It says, well, it finds me the model with the name OO. And by the way, I do not want to be it transient, meaning this will be persistent. So if you do true, then it will be there. If you exit the system, then it will be removed. So you can choose either. Doesn't matter for the rest of the semantics. And of course, there's something with the model, and I'm going to create a rule for that. I'm going to say this is just what we are used to. So the OO model has types, and those types are this is the module, my models, then all the roots of the type model. This is the factors model thing. Then all the object types, and then from that, of course, the OO. So now we have created a model, and we say all those OO things are part of that model. That's it. what's wrong? I did something wrong.
It's a node pointer.
Sorry?
Shouldn't it be a node rather than a node pointer? No, attribute. The OO attribute.
This one?
Yes. It has a node pointer.
Oh, yes, thank you. Well, you know, type system.
Why you would use node pointers?
What is proof the type system is? People make mistakes, I'm good so, but gradually, this is not some reflective solution, it actually helps you to prevent you from errors. It is solved. Where am I at the time? So let's create the lexical object. So create rules, lexical. And lexical object, of course, there I have to define what my OO actually is. Rule. So the column is equals means a kind of assignment, but it is actually an equation. It means this should always be the case. It's like an Excel sheet where you put a formula in a cell. This is what it is. It will always have that attribute having that value. But the same counts for the roots. So if something is added or removed, it's going to be added and removed. So you don't have to subscribe and if something added, then I have to add it. If something is removed, then I have to remove it. You just say this should be the case as a functional specification. Sigma. And this is of course simple. This is the OO type, and I will show you why. OO type is actually defined as a reference in a lexical object type, and it's enumerated. And you see it over here. It's the way to go. You get a necessary model for your long objects that are always there in the library. And if you see here, a boolean refers to the OO type boolean, and the text refers to the OO type string. And you can change this, and we will incrementally whatever. This is what I just say. So we have an enumeration of all the lexical object types, and we can edit it in a simple way. Okay. Now we have to do the now it becomes really interesting, of course. The non-lexical object type. We have only one rule here, again. We have OO, and here we want to have the right quotation. And what is it? It's close. So, and then we already saw this one. And then I have to do something which I can't express yet. So because I want to have fields, fields here, and you always need to think in light quotations when to do the heck or not. But you get used to it. I don't know if you all have experience here. But I want to do something like this, and then roles. But then you would say, well, I do the roles for all, but that's not the case, of course. Because the role that I am playing is the role that me referring to the other role. If you look at the sales example here, then this role is my role of customer, because this is the opposite. That's what we have defined with the tilde construct. And here, the name is actually the one that I want to be part of customer. So I need to have the opposite, actually, of the other. So, so we're going to define the concept opposite. So it's just that you do create if you need a concept, create an attribute and create a rule that defines that concept. It's as simple as that. So if you go to rules and we create a rule set, then we're going to define node. this is also role, and it's opposite. Is it opposite or opposite? Opposite. And it defines this. It says parents, and it's fact type, and if it's the left, the row, and it's equal to myself, then probably it would be this dot parent dot fact type right role, right? So if I'm the left role, then my option is the right one. Clear? And otherwise, it's this. And you see, this becomes annoying. Don't you think so? Parent, fact type, right role. Yeah. So what I would like to do here is actually, because this is a concept that repeats itself. So what I can do here is say, hey, this is broken. I'm sorry. Yeah. Oh, it's here. Thank you. No.
You have to select.
You have to select the thing that I want to change. You don't want to
Oh, sorry. Yeah. So people understand it better than myself, which is great. Refactoring, extract attributes. So now we have attribute name, which is a little bit strange, but what we mean by this is the parent. Yeah? Or let's name it. It's the. Sorry, I will. Yeah. So this makes it more convenient. Can I answer your question after I finish the rules? Yeah, just.
Shouldn't the right role be left role? Yes.
No, if I'm the left role, then the opposite will be the right
In
role.
both cases, you have the right role now.
I rest my case. Okay, so now we have opposite, and now we can actually say here, opposite. Oh shit, we didn't find anything what the semantics is of a role in terms of OO. Yeah, we didn't do that yet. So what is something, what could be a role? It could be a field. I just named it field like in Java. Otherwise, if I name it attribute, so this is also O. So any role has a field. Although, if we have a lexical fact type, then probably not. Yeah? Yes, thank you. So I'm going to stop this. I'm going to go back and show you just what it is. Yeah? Don't have any objections. Because otherwise we run out of time. Pause. You experience MPS users. So if you look here, it looks like this. Now we have build and the rules here. Here we have the rule set. here you see it's just another one. It says if it's non-lexical, I have a field otherwise null, and it's optional because I don't want a primitive type text refer back to customer if coincidentally that string is the name of that customer. So if it's a primitive, it's only one way navigatable, and that's why this is optional. And this is explicitly defined, but if you do not define optional and it is not derived, you will get an error. So the consistency of your specification in terms of references, orphans, all the rules should not conflict, the scoping should be okay, the timing should, everything, otherwise you have a problem. And I will show you one other thing, and that is the sudoku. Here we have sudoku, and we're not going to solve it here, but you see the green fields are actually already derived. If I look in the expector, and you see there's only one value here, and here I see multiple values. So I will show a small one. Actually, here all two. What are possible solutions for? Not. Because why? Here there's nothing left. It's just if it's oh. Just a second. So this is a solution, and actually it's a complete solution. This dimension, but it would touch the other one, which is we don't have time. So question. Okay. Any questions? Oh, you have one.
Yeah, I was just wondering why you didn't define a behavior method instead of this conditional method. Is there any difference, trade-off?
Yeah. Actually, if you create such an attribute, then it's cached, and your incremental behavior goes more locally, because then only the other rule that uses the attribute is only triggered if that attribute actually changes, which is not necessarily the case if some of the input of that is used. So and behavior has also some overhead, and if you create big rules which read a lot of models, of course, then you lose locality. So the rule of thumb is keep your rules as small as possible.
Did you use it in other aspects? Other MPS aspects?
Not yet. We are experimentally a little bit. Of course, this is just it's just the rules aspect. So we didn't create a transformation or an interpreter aspect. But we have created in JDclare, for example, a parser editor. So you can do all kinds of stuff.
Could I, for example, now call into this new thing or in an intention?
You can't call the rule thing. But the whole point is, if you call something, it's an imperative construct, and rules are just there. You can't rule. The rules doesn't have any names. They don't have a signature. Of course, you can do it the other way around. You can call a behavior method within a rule, if you're careful. So that's not the problem.
The point is that you make a rule set as small as possible.
Well, the rules actually are small.
Yeah.
Okay.
Can you show the rules for the sudoku that we get a feeling?
Yes, I can. These are different rule sets, and this is actually such a node. It's the cell logic. So it's a kind of, so you can create structs with rules that are derived by other rules, which are not necessarily instances of nodes. But then you can define which things identify this structure. And it's in this case, it's a set and a certain filling. Because we can only derive whether it's green or red based on the things that are fixed on the filling. Because otherwise it will feed back into the filling again. You understand what I mean? So the filling is actually the thing that you, as a user, filled in stuff. And this is just a list of values which identify this concept. So you have to think about these kind of things, but this is exactly an example as Marcus asked, that you need for an interpreter, you need other objects. And here you see the rules that actually calculate the taken by others, the possible left, and if the size is bigger, then you can, and this is recursively rewriting, it says fixed point semantics, the system, because if you have less for one cell, then this can have impacts on other cells, and it just goes to the fixed point, and then you know whether either it's still possible, or it's completely solved, or it's unsolved.
Now here, change the editor inside the rules, right?
Yeah. So this is an example of a so-called in-place transformation. If you look at this one, I illustrate that. So I'm just now created a different dimension. So you see, this is an attribute in the same concept, deriving the structure within itself.
Yeah. My question is what was now you interactive MPS. This was what my previous question also aimed for. So you can change the editor.
Well, you can only change the nodes, and the editor changes because of the nodes changes.
Okay, so the color depends on the attribute of the node.
Yeah. But it's just, if you create behavior that changes the nodes, it will also refresh your editor. We don't have to do anything, but that just works in that way. So, but if you don't want to show it, and it's just underneath, then you create these structs. Yes. Sorry. If you have more questions.
More questions, a little bit, maybe one or two more questions?
Sorry?
Maybe one or two more questions?
Okay. One question?
Nobody else wants? Can you do it the other way around? Can you call from from the rules into, for example, creating a type system error or
Yes, but indirectly. For example, we did a tax office an experiment where we actually created checking rules using it, which is not a bad idea because then it's always validated. We did it over the editor. But we have a kind of framework, and there's just one checking rule that says, well, there are problems, and then we have problems in the model, which are just attributes, and those are synchronize. Yeah. So we didn't invent any new concept, but giving these primitives, you can solve a lot of these issues automatically. It's just you need to do this. Of course, I'm not against DSLs. Thank you.